see. I'm going to hold like this, and then... Oh, hi, sorry. Oops. I was just practicing because I'm going to be going on a roller coaster a little bit later, and I wanted to practice my facial expressions. How'd I look? Did I look okay? Phew. Didn't think you were watching. Anyway, it's actually pretty good that I was doing that because it reminds me of a riddle that involves roller coasters. Let's take a look at it together and see the ups and downs of this question. All right, a king-to-car train has 4 seats per car, but the last car has only 2 seats. The question is, how many seats are on one king-to-car train? Well, let's take a look at this little table which shows the cars per train for different roller coasters. We're looking at the king-to-car, which we see if we go up to this end of this bar here, we see 5. It means that there's 5 cars per train. Now, we're told that the train has 4 seats per car, but the last car has only 2 seats. So there's 5 cars, but that last one, the 5th one, has only 2 seats. The rest of them, the 4 others, will have 4 seats. So let's figure out how to view this. Well, I can kind of show it to you. In fact, I'll show it to you, and I'll actually bring it on like a roller coaster. You ready? Here it comes. Whoops, here it comes. Ready? Okay, I think you get the idea. So let's check it out and see this is really right. So we see that there's going to be 5 cars, and the cars are represented right here. 1, 2, 3, 4, 5. And notice that each car has 4 seats, and you can see that right here, 4 seats, except for the last one, which has only 2 seats. And so this represents, in fact, 1 train on the roller coaster. So how many seats are there? Well, of course, you could just count them, but that's not the point. The point is to realize there's different ways of actually systematically making sure we count everything and do it correctly, because you might lose count as you're going through. So let me show you one way. One way is to lasso these green cars together like this. Whoosh. Whoosh. Now, when I lasso it that way, how would I write that? Well, I would write that as I have 2 times, because I have 2 of these things, I have 2 lassos, so 2 times, and then 2 times what? Well, notice that I have groups of 2, group of 2, group of 2, group of 2, group of 2, and how many groups of 2 do I have? I have 1, 2, 3, 4, so I have 2 times 4 groups, okay? And that's for the top red circle, and then I have a bottom red circle, and that's why I multiply by 2. So if I work now, and then don't forget about these 2 guys hanging out there, little hangout guys. Little hangout guys, little hangout guys. So now, if we notice that we have parentheses, we always have to perform the operation inside the parentheses first. So that's going to be 2 times 4, which is 8. So this is going to be 2 times 8, and then plus that 2. And notice that checks, by the way. 1, 2, 3, 4, 5, 6, 7, 8. Yes! Now, 2 times 8 is 16. And then we have to add the 2. Because remember, we do the multiplication first, and then we add the 2. That's always the rule. And now 16 plus 2 is 18. So we see the answer is 18. There must be 18. There must be 18 seats on this particular train. But there's another whole way of looking at this. And I want to show you the other whole way of looking at it, because it's kind of interesting. It allows us to kind of see math in a different way. So let me just slide everything up here. Slide it up a little teeny bit. There we go. And now what I'm going to do is I'm going to bring the train down. Boom, it's like a free fall train. You ever go on those rides where the thing just falls? I did that once, and that was really scary, by the way. Really scary. Some people like that, but I was like, I don't know if I like this or not. And they were like, oh, yeah. Okay, now, another way of grouping this is to realize that I can look at these as little pockets right here, these the cars themselves. So let's look at the green cars, and if I put them all together, car by car, then I'd be grouping like this. And when I do that, what do I see? Well, now what I see is that in each little car, I have 2 times 2 seats. 2 times 2 seats. So now I could write this as 2 times 2. That's for each, this car right here. And how many cars do I have? 1, 2, 3, 4. So I'd multiply by 4. And now what does that give me? Well, 2 times 2 is 4. Oh, wait, David, don't forget. Wait a minute. You almost, why didn't you forgot about the plus 2. You silly friends. All right, you got to put in the blue plus 2. Phew. Okay, now back to work. So let's focus on the thing that I was focusing on before. You always do what's inside the parentheses first. That's going to be 2 times 2, which is 4, times 4, and then don't forget the plus 2. We always do the multiplication before we do any addition. So this means 4 times 4, which is 16. By the way, the 2 times 2 is 4. You can count for yourself. 1, 2, 3, 4. There's the 4. And we have 4 of them. Now, 4 times 4 is 16. Plus the 2, and this should sound familiar because we've seen it before. 16 plus 2 is 18. So check it out. We get 18 this way, and we get 18 this way, and that's because we're seeing a wonderful example of associativity in multiplication, which means that we can either multiply, if you have 3 numbers that you're multiplying together, you can either multiply the first 2 first and then multiply by the last one, or you can actually take those parentheses and slide them over like a roller coaster. Woo! And it goes over here, and you can do that multiplication first and then multiply by 2. See the difference? The only difference is the parentheses. Woo! 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 So that is really an excellent example of associativity in multiplication. And it allows, actually, for easy counting. If you were to try to count them one by one, you might lose count. You might kind of count something twice, and you might get the wrong answer. But with associativity and systematic thinking, you will always, always get the right answer. Yes, I know sometimes the questions are challenging, and it feels like you're on a roller coaster ride through mathematics. But remember, it's just as exciting and just as exhilarating as riding a real roller coaster. I better practice that again because I want to look really good when I'm on the roller coaster. So I'm going to grab the thing. All right, you ready? Tell me how it looks. Woo! Ah!